Welcome to my final project presentation for CIT 260. My name is Dana Herdlick, and I will be your guide through my object-oriented programming game design for S.N.I.P.E Academy. Let's get started. Because Java is an object-oriented programming language, we will need an object to access any method or variable inside or outside of a class. When the keyword static is used to declare a variable, that variable becomes a class variable. All class variables share the same location in memory. A class variable can be accessed directly within the class, and we don't need to create an instance of the variable in order to use it. Here we created static variables, current game, player, and log files that will be available throughout the program for the entire game. Because there is only one game or player or log file each time we call upon them, they will be using the same location in memory. When a non-static variable or instance variable is created, it is specific to an object of the class. Memory is allocated each time a new instance variable is created in the class. We used instance variables for the display description and answer option in this example from the challenge physical view because they are only needed inside this block of code. The display description will show a message welcoming the player to a country that is specific to that country. Once the block of code is completed, the instance of this variable is removed from memory. Here's an example of a static and non-static functions. They have the same characteristics as the static and instance variables. On the left, we have the static createNewGame function. It is used in our game to start a new game and receives the player variable. The cipher control on the right is a non-static function from the cipher control view. It's only used inside this block of code. It's called by the Safe House view when the player completes the last challenge of the game in Australia. It will display the cipher decoder using this console println. When we had a fixed length of objects or primitive values that store multiple variables of the same data type, we used an array. The reason we used an array in the getCode function, in the getName function that randomly generates the player's code name is because the length of the string arrays names1 and names2 is fixed. The individual names in each position are updatable, but the list length will always remain the same. The code randomly iterates through each array, selects a name from each, then displays both names as the player's S.N.I.P.E code name. When we need to dynamically add or remove objects from a list, and the objects of the same data type, we used an array list. We built array lists in our player function for the passports and code list. This allowed us to dynamically grow the list of passports as the player visits different countries, and allows the code list to grow as the player collects codes for successfully completing challenges. When the number of elements in a list is fixed and the elements are unchanging constants, we used an enum. Once stored in the enum, the elements cannot be changed. The reason we used the enum in the dossier list is because it is a fixed length of countries, each with its own unique welcome message. Referenced by a keyword that described the country dossier corresponding to a player's current location helped me better understand the code. The value of using arrays, array lists, and enums comes when we use statements to loop through the list to find a particular object. This is the map menu view. The list of countries is placed into an array called countries. Using a for loop, we iterate through the array of countries and then jump into a nested loop of places. The nested loop iterates through the places array to link the places within a country to that country. This function prints to the console the names of the countries along with their associated places. Once this instance of the map menu view is created, the console prints a map and the code block is completed. At this point, this instance in the memory is removed from memory. Program-specific errors occur when a player tries to type invalid data or perform some action that's not allowed. Rather than having the program end abruptly and displaying an ugly error message, we throw exception errors and display messages the player can understand. Exception handling makes the code simpler and easier to understand. We want to surround the statements that create the file streams and read-write data to and from the file stream in a try-catch statement. Let's take a look at a custom runtime error that we created for our S.N.I.P.E game called game control exception. In our game, we have this game control exception. When a player wants to start a saved game, the program initiates from the S.N.I.P.E.java main function, which calls the display start program view. The display start program view calls the start saved game view. If the player chooses to view the report on the codes he has previously collected, the write code list is called. Each step in this process can throw a game control exception error should something go wrong. If there is an error writing the code list, the write code list function throws a game control exception back to the start save game function, which then throws the game control exception back to the display start program view, which then throws the game control exception back to the S.N.I.P.E.java main function. It is here in the S.N.I.P.E.java main function the game control exception is caught, and the stack trace prints out the error message indicating the cause of the error and returns back to the function, where a custom error message is displayed to the user. A stream is simply a sequence of data. Input reads data from the source while output writes data to a destination. In Java, characters are stored in Unicode encoding, which automatically allows reading and writing data character by character. This is the most useful when processing text files. Byte stream is used for processing raw data like binary files, byte by bytes, composed of ones and zeros. The strength of the character stream is using that 16-bit Unicode, reading and writing character by character. This supports all languages, and the syntax here is from the keyboard is buffered reader, and writing output to the console is print writer. Character streams are tied to string and character types, where a byte stream uses only ASCII character set. It's only 8-bit, non-Unicode, which means it doesn't encode the scheme, and it just reads it byte by byte. The syntax for input is system in, data input stream, system out, data output stream, and system error. Byte stream is not flexible nor modular in design, and it's error-prone for language translation. So it's important to always close the file stream when no longer needed because it will impact the computer's performance. This is because the operating system locks the file when a new file stream object is created, so no other process can read or write to the file while the program is using it. This is the write code list function. We create and open a file stream using the print writer for the output file stream object. We then write the data to the file stream and run it if-else statement to check to see if the code list is empty. If there are codes in the list, we run the loop to get the list of the player's codes. We write the list to the output and save it as mygame2.txt on our computer. We then flush the data from the file stream, and then after checking for the exception error, we close the file stream. Now let's take a look at our game, and let's try to see how it works. Well, welcome to S.N.I.P.E Academy. Let's log in. Look, it welcomes us to S.N.I.P.E Academy. Let's go ahead and start a new game. Okay, as we can see right here in the center of the screen, our S.N.I.P.E code name is Red Ninja. That was that random generator that used those arrays from earlier. Let's go ahead and travel, and we're going to go to the Library of Congress. We read through the text and we answer the question because we know the answer. Oh, great. Look, we got it done, and we're correct. We know that the program is working and it's calling the different pieces. Let's go ahead and travel, and we're going to go to S.N.I.P.E Academy. That's our safe house. Notice that that went ahead, and it said we're at S.N.I.P.E Academy. Our mission in the USA is complete, and here's our dossier for the next country, which is Germany. Let's go ahead and view view our map so we can see where we are. This is a demonstration of all the S.N.I.P.E Adventure places. This was that nested for statement that iterated through the countries and then iterated through the places and built our map. So let's go ahead and return to our player location. Let's go ahead and let's view our player health. And our player health currently is at 100 points. That's really good to know. All right, let's go back to the main menu. At this point, let's go ahead and return to player location. If we wanted to print a list of the codes or passports or the list of the countries, as you can see, we just have to hit some numbers and go here. We don't really want to do that, so we're going to go ahead and go to the Help menu. And as you can see in the Help menu, it tells different things that we can do that will help us along our way. It tells us exactly what we need to know for it. Let's go back to the Game menu. Let's go to the Travel. And from Travel, let's go ahead and save our game. It asks us what we want to save our file as. Let's go mygame15.txt. Okay, and as you can tell, now we know that our game is saved. How do we know that it's saved? Well, let's go ahead and let's shut it off. Let's reinitialize it. Let's sign in. Let's go ahead and load an existing game. And we saved it as mygame15.txt. Sure enough, look at that. It takes us right back. Let's go ahead and travel. And it tells us that we're right here at the Berlin Wall at the Cologne Cathedral. Same place that we left off. Let's go ahead and come out. Bang. And that's a demonstration on how our game works. Well, here's some resources that I used when I was putting the game together. As you can tell, they're pretty helpful. Well, thank you for joining me on my journey through object-oriented programming. I hope you enjoyed our S.N.I.P.E game and will come back and enjoy it again soon. Thank you.